In this video, I want to look at Larson Chapter 3, Section 1, exercises 1 through 6. And we're asked here to find the value of the derivative, if it exists, at each indicated extremum. So first of all, we have a new word here that we may not have encountered before, and that is extremum. Extremum is a Latin word. It just means an extreme value. It might be minimum, a low point on a graph, or it might be a maximum, a high point on a graph. And in this chapter, we're going to talk about two types of extreme values. And in these 6 exercises, though, we're specifically concerned with one of those types, which we will call relative extrema. So we might be talking about relative minimums, and we might be talking about relative maximums. So let's first define what a relative extrema is. Let's look at over here at example 5. A relative minimum is a point on a graph that is lower than the points immediately to the left or right of it. So a relative minimum, if you look at example 5 there, at -2, 0, that point is lower than the points immediately to the left or to the right of it. So we call it a relative minimum. And a similar definition holds for a relative maximum. A relative maximum is a point on a graph that is higher than the points immediately to the left or right of it. So you can see that in exercise 6 there, you have that peak value at 0, 4. We call that a relative maximum because that point is higher than the points immediately to the left or to the right of it. It's relatively higher than the points on either side of it. So the first thing that we want to talk about here are relative extrema. And you can see in each of these exercises there are examples of relative extrema, points that are either lower than the points immediately to the left or right of them, or higher than the points immediately to the left or right of them. Now, what we're asked in these 6 exercises is to find the value of the derivative, if it exists, at each of these relative extrema, at each of the indicated relative extrema. And the indicated points are the ones where obviously you have points there and you have coordinates labeling them. Now, in number 1, what is the value of the derivative? Remember what a derivative is. The derivative is a slope of the line tangent to a curve at a particular point. So I just noted that there. A derivative, or a derivative, is the slope of the line tangent to the curve at a point. Well, at point 0, 0 in number 1, what is the slope of the line tangent to the curve there? The slope of that line is 0. So the derivative at 0, 0 is 0. And we would write f prime of 0 is equal to 0. In number 2, we have both a relative maximum and a relative minimum, relative maximum at 0, 1, what is the slope of the tangent line at that point? Well, it's a horizontal tangent, and so the slope at x equals 0 is 0. And the slope at x equals 2 is also 0. So notice that it didn't matter whether it was a relative minimum or a relative maximum. In either case, the derivatives are 0. And number 3, we have a similar scenario. At x equals 2, we have a minimum point there, a relative minimum that's lower than the points to the left and right of it, and we also have a horizontal tangent to the curve at that point, so f prime of 2 is equal to 0. Number 4, at negative 2/3, we also have a maximum, and there is also a horizontal tangent there, so f prime of negative 2/3 is equal to 0. So just by looking at these 4 examples, you might be led to think that whenever we have a minimum or a maximum, the derivative is always going to be 0. And that is the case as long as the graph is smooth at that point. But in number 5 and 6, we're going to see 2 examples where the graph is not smooth at that point, and yet we still have a minimum or a maximum. So in problem number 5, we have a relative minimum. It's a point at negative 2, 0 that's lower than the points immediately to the left or to the right of it, but the derivative is not 0 there. What do we say about the derivative there? F prime of negative 2 does not exist, and it doesn't exist because there is a sharp turn there. Whenever we have a sharp turn in a graph, there will be no derivative at that point. Same thing holds for number 6. We have a sharp turn at x equals 0, and so we would say f prime of 0 does not exist. We don't say equals does not exist, just simply does not exist. Alright, I'm going to draw a conclusion here to all of this. We have a definition of relative minimums and relative maximums. And I'm going to draw this simple conclusion. It says, whenever there is a relative minimum or maximum in a curve, the derivative there is either 0 or does not exist. So this is the main thing to get from this. We have a definition of relative minimums and maximums, and we have the fact that whenever a relative minimum or maximum occurs in a graph, the derivative will always be 0 or does not exist. So these are the essential things to take away from this slide, and we'll go on to the next in the next video.